Greetings to all of you. So, here is a DBMS series. I hope you started a computer network series, and I uploaded the video previously before this series. So, we are starting with the transaction management, which is a very far away topic from the basics. But uh, this is the video for those who have some knowledge, basic knowledge about DBMS, so they can watch it easily. So let's dive into transaction. So transaction is a logical unit of work made up of one or more statements that execute as a single indivisible action against database. This is the definition written here. In layman's language, transaction is a set of operations to perform a task. And this is a DBMS, so we use SQL language in this. So when we write one query, it's a single statement, but the group of statements in a sequence is transaction. For implementing transaction in SQL, we use start transaction, begin transaction, and commit or rollback on error or something else. So, asset property of transaction. A stands for atomicity. Atomicity says that the transaction should be complete or nothing done. That means you start a transaction, you should complete it, or you should not start a transaction at all, or do not complete it. There should not be any variable. Either you complete it or it should be incomplete. That's atomicity says. At some point, transaction stops and continue from there. This is not allowed in atomicity property. Coming to the C of acid, which is consistency. When the database changes after one transaction, the data inside the database should move from one valid state to another valid state. For example, if in a transaction I have 100 rupees in my account and 100 rupees in my friend's account, I paid him 20 rupees. So my account says 80 and his says 120. Now the sum of both account numbers before the transaction is 200, 100 each, and after the transaction it's also 200, 80 plus 120. So there is no data loss or inconsistency. That's called consistency, that you move from one valid state of data to the another valid state of data. Coming to the isolation, one transaction in a schedule we will study the schedule in this video later. One transaction in the schedule should not disturb the other transaction. If one transaction is happening, it should not write after the before writing the other transaction. We will talk about read write operations in transaction. But for example, for understanding this, I have 100 rupees. The same example, my friends also has 100 rupees. For example, my friend want to send 20 rupees from the account to me. So what if after transaction fails after deducting the amount from my friend's account? My friend's account shows 80, my is still 100, not 120, and it is there is a error in between the transactions. What happens then? What happens? Transaction continues from there and write that my account balance is 100. This is the violation of isolation. No transaction can write the data of the other transaction before updating it completely. My account balance was not updated, but the other transaction of my friend forcefully updated it. This is not allowed. This is just an example to show this is not allowed. Durability. So, when the data moves from the temporary log, moves from the temporary log to the permanent database, there is no change in it. That's D in asset durability. It doesn't change, it doesn't crashes, it will be there whether it is a power loss or some crash of database, it will not change. So here we can see the control commands, transaction control commands. So we have begin, commit, rollback, save point. We will study about these in this video. Now the transaction state. When the transaction is being made, the transaction is started. There is also a stage where transaction is created, which is just not mentioned here. I should add it. I will add it afterwards. So after creating the transaction goes into the active phase. The transaction is being implemented in the system. So there are states like partially committed. If the transaction is complete without fail, then the active state goes to the committed state. If the transaction is on pause, then it goes to the partially committed stage, which says that it is committed, not some statements of the SQL, not all. If it fails, then it is failed state, and from the partially committed, if it committed some statements but it is not committed all the statements, then it goes to the aborted and then failed. So from active, can go to fail directly, can go to commit, it can go to partially commit. From partially commit, it eventually goes to failed state via abort. Commit means committed means the data is updated in permanent database. Active is the operations are being performed and updated in temporary log. Partially committed it. Some steps are completed, but some are left. Failed is that the transaction has error and it's rolled back. Let's move to the next slide. So, as I have mentioned about the begin start transaction, which moves through the transaction from the create to active state, there is a command in structured query language syntax called begin or start. In PostgreSQL, it's and in SQL, it's different. Begin and start. It means marks the start of the transaction block. Commit. So it is a make all changes in transaction permanent. Commit. Rollback. If error occurs and we want to undo all changes to maintain the atomicity, we roll back. Save point. I told you about continuation of the transaction from that point, which leads to some error I told you before. That's continuation starts with save point. Roll back to save point. Undoes only the work done after the name save. So this is a partially committed type state. We roll back from the partially committed thing. So that transaction configures isolation level or access mode terms. Yeah, we'll talk about these. Now there is an example for committing a transaction. So we have statements. We started a transaction. We are finding a balance from the yeah, we select balance into from balance accounts. Okay. So account ID A101. We're selecting the balance and we are updating it. Its balance is greater than or equal to 500. We are we are deducting 500 from that account and we are adding 500 to other account. So here the transfer of money is happening. The example I gave to you about 100, if they are in this example they are taking 500. They selected the balance and they made a variable called add balance. They put into that from accounts table where account ID is A101 and they updated the balance A. If it is greater than or equal to 500, then they update the balance and deduct the 500 from the balance of that account and add the 500 to the other account which they want to transfer and commit the transaction. If balance is not within 500, then what they do, they roll back. The transaction is not completed, it is undone to ensure the atomicity asset costing and the condition is and if condition is and. So here we discussed rollback, we discussed commit, we discussed start transaction, how transaction happens, how the things are moving. I explained the SQL query to you. Partial undo with save point. Now we are doing the partial commit thing. Now we start the transaction. We are inserting values into the orders table 101 allies 2250. Now we have save point. Means we are putting a tag that we will continue from that point after some time. Then we insert one more value to the order 102 Bob minus 150. Minus 150 is invalid. So it makes it creates an error. So roll back to SPA. That means roll back to the save point that we have tagged before that for until which the transaction is right, we should move to that point, which is the save point SPA. So it says roll back to SPA. Then we commit the transaction. So it's explain the partial committed transact state or fully committed state. So if there is no isolation, transaction can read, write each other's data. What happens? These are some of the anomalies happen. Dirty reads. I told you this. T2 reads a row that T1 has modified but not yet committed. If, for example, if on my account 20 rupees deducted and same example of transferring 20 rupees from my account to another. If 20 rupees is deducted from my account, remains in 80. Then, for example, another transaction reached my account and says, yeah, Tushar's account has, my name is Tushar. Tushar's account has 80 rupees. Another transaction is. What happens then? What happens then? The whole transaction, bank transaction failed. Error occurred. My money deducted, it doesn't came back, and and it is shown that my account has 80, which creates an isolation violation. Another transaction reads my account and updated it, but it is not updated. Actually, it is not modified in the permanent database, but they showed it. That's studied when you read a row that has been modified but not committed or not updated. Committed means updated in permanent database. It is not committed yet, and you read it before. That's studied it. Reading before committing is dirty. Let's move to the last update. For example, T2 and T1 have both read the same row and both write Rex on the stale value. Once transaction will silently overrides the other. Yeah. For example, there are two. There is a paper. Paper example is very layman example. I'll tell you the professional one later in this video. So, for example, I wrote 100. My friend wrote. There's a database which shows 100. I read 100, my friend read 100. Then we both write our own database. I write 120, my friends cut it and write it. So silently, my friends write in my data. So this is called lost update. I updated the data from 100 to 120, but my friend wrote it 80, which also creates an isolation that two transactions are disturbing each other. My friend is disturbing me and wrote it without my permission. So this is also an anomaly. So let's non-repeatable read. For example, T1 reads a row. Here T is transaction. T1 reads a row twice in the same transaction and gets different values because T2 completed an update with it. Okay. So, for example, the same paper example, I read the paper and I wanted to read the paper. I want to read paper twice in a day. So I read the paper and I saw there is written that your account has 10,000 rupees. I read it and I go somewhere. When I came back, it showed your account has 8,000, 2,000 decreases because somebody came and updated my account balance without my permission. So I am one transaction and another transaction come and still it disturbs it. And I read two different values. This is called non-repeatable read. When I read two different values because someone updated it in between. We covered this in transaction terminology format. Phantom read. T1 reruns a range of query and finds a new rows that were not there before. T2 inserted matching one. Yeah. So it's similar to non-repeatable read, but what it deals with a row in a table in SQL. If you are not beginner in SQL, you know basics. So you should know that the table has rows. So when I read the table first, I found 5 rows. But when I rerun the query, I found 10 rows because when I rerun the query in between, and another transaction happens and increases the row. So this is called phantom read in case of row, and in case of the data, it's non-repeatable read. Lost update is there that if you both write on same data, dirty read is there. If you read which is updated but not modified, let's move further. Isolation level. Read uncommitted. Dirty read possible. If someone read and it is uncommitted, yeah, dirty read is possible. Because I have read but it is uncommitted. Another can write and then I read it's become dirty read. Non-repeatable read. Yeah, same thing can happen. If I read now, somebody updates it and I read again, then same. Phantom read can also happen. Phantom read and non-repeatable read is somewhat similar, but phantom read deal with row and non-repeatable read deal with the data. Now read and commit it. Now the isolation level is we read it and committed it. So dirty read is prevented because we do not write after it. We have read it and committed. That's all. So, but the non-repeatable read is there because we did it, but anybody can write it and twice same phantom read can also happen. Similar things. Repeatable read, session level, prevented, feedback. So there's all about the repeatable. Now the repeatable read is there. It's the reverse of non-repeatable read, and you should not read, you should not update in between any transaction. So non-repeatable read is prevented in that. And dirty read is already prevented because if you are not writing after reading one data and do not create an update and then read the data to create a phantom to do the read sorry, no phantom. So yeah, but phantom read is possible because of there are n number of rows to deal with rows which do not deal with the data. Serializing. So here we are starting new topic serializability. This table shows that if we increase the isolation level, then as the analomy anal, oh, I'm sorry, anomalies decreases. If we increase the isolation level, anomalies decreases. Let's move to the serializability topic because the last row should and second last is not understood by you all. But if you understood up 60 to 70% of the content, then you're good. Now, schedules and serialize. So there are schedule is an order in which operations for multiple transactions actually execute. So we have multiple statements in a transaction. Similarly, we have multiple transaction in a schedule, which is in order for the execution. The job is to allow concurrency while guaranteeing that results matches some serial execution. That you the execution should be serial. There is no cycling. Now we have something. Uh, we have read the definition of schedule. There is an example. We transaction one read, write, commit. Transaction read, write, commit. No overlap. Correct. Now in concurrent schedule, T1 read, T2 read, write, commit. Lost update risk because when T1 write and commit, the T2 also writes the same data and commit. So it changes the data which T1's write, which is an anomaly we covered. What is the name of that anomaly? You should be commenting in the comment box. Now, how do we control the concurrency in when the transaction is inconcurrent and causing the anomaly? First is to schedule the transaction, make it serial. We will cover the serializability and serial transaction in detail in further videos in database series, but this is the video with some introductory part and some hints to give you detail. So locking and two-phase locking. So when you put a lock on the transaction, it guarantees that nobody can write after the read after the reader, or nobody can read after the write. Sorry, and whether there is a problem when the pair of read write, write read, and write write is there. So you should be applying the locking and two-phase locking, which locks the transaction and does not allow other transaction to read or write it. But if we lock the transaction, we can we can move into the phase where deadlock happens. So to counter that, there is another locking technique to maintain the concurrency. It is two-phase lock. When we acquire some locks on specific points and we just release the locks, we will discuss this in upcoming videos. What is deadlock? Deadlock is a very important topic in operating system and also DBMS. Deadlock is a condition where transaction holds a resource or a row which is holded, which is requested by other. For example, I'm the guy and I want the chocolate, and there is only one chocolate on the table, but the other guy have it, so I can't take the chocolate. But I have the chocolate that the other guy want. He is requesting, but I have that chocolate. So it creates the cycle, vicious cycle, that I want his chocolate, he wants my chocolate, but we both are using that chocolate, we are eating it, so we can't give. It creates a deadlock when resources are engaged in a cyclic fashion. Similar with the transaction, when transaction holds a row and other transaction requests the row and waits for it, it's become a deadlock. So here is a SQL example in it when we see that it is updating the two updating a date data in a table, but it cannot do the thing because T2 holds B. So same thing happening with T2 deadlock happens. I see it is written as I mentioned in my example of chocolate. Update T set where ID equal to A, update T set where ID equal to B. And in transaction 2 it is written update T set ID equal to B. Yeah, it's transaction 2 holds B but transaction unrequested transaction holds A. Yeah, but it does but transaction is requested. Let's move to yeah so this is all about transaction. It was a very good session. I hope you understand a bit. This is my new channel. You should support it by subscribing my channel, hitting the like button to keep me engaged, and comment any of feedback in the comment section. It is full of devotee. So thank you for watching up to this mark. Bye bye.